Okay, in this video we're going to talk a little bit more about initializing arrays. At the end of the last video I said I haven't showed you how to set an individual item. I actually had shown you how to set individual items. That was the first thing I showed you how to do. But I did want to show you before we go any further that once these items are set, okay, initialized, we can change their values just like when I was initializing them in the previous video. I can say fruit sub 2 equals potato if I want to, and I screwed that up. Potato, which isn't a fruit at all, but we'll use it just for this example. Fruits sub 2. So this is item 0, item 1. Item 2 is grape. So we're changing the value of index 2 to potato, and then this is printing them out just like it was before. Go ahead and run that, and you can see item 2 became potato. So in this long list of strings, if I had 100 of them, initializing them like this one at a time could be quite time consuming. However, if we're initializing a bunch of things like this, we could load items from a file, we could load items from a database and insert them into an array. So let's take a look at some other ways to initialize besides doing them individually. I could do something like this. Let's go back to, we'll stay with fruits for a minute. New string of 7 items. Okay. And what I could do is use a for loop here. So you're going to see a for loop contrasted with a for each loop. So we'll do a for loop like we had before. Int I equals 0. I is less than. I'll go ahead and use fruits.length. And I++ for our incrementing. And in here, let's initialize. Well, first I'm going to skip. I'm not going to initialize it. I'm not going to do anything. I want to show you what happens if I try to access. I created all these new strings, but I've never set any of them to a value. Let's print one of them. This was print out fruit sub 0, which is, it was apple. Excuse me, fruit sub 0. And we get null values. And depending on what you're doing, null values can cause your program to crash. You can get null reference exceptions and all kinds of things. So it is important that when we create things like strings, that we initialize them. So if we're not sure, we can read them from a file to initialize them. We could use the curly braces like we did before. I'm going to do something different here. Fruit sub I equals, maybe I would initialize them all into unknown. So at least they have a string value assigned to them. Okay, and we'll print it out. Now they'll all print out unknown. So it's important to initialize your variables. What about integers? So let me get rid of, before I do, for loop using index numbers allows us to set values. We set the value of each item here to the word unknown. A for each loop, there is no way to set the value because we don't have a number to use as an index. Okay, so that's why that's part of the reason a for loop isn't good for setting values. A for each loop is not good for setting them. A for loop is great for setting them. For each loops are nice and succinct for accessing values and printing them out or running through them and using them for something else, but you can't actually set the value in here. All right, let's look at a different array. Let's do an array of ints. I want to call it my ints equals new array of integer size 10. Okay, so this is going to be an array called my ints that holds 10 integers. Let's use a for loop to initialize it. For I equals 0. Oops, forgot to declare type int I equals 0, while I is less than my ints dot length I plus. Okay, there's my loop. What can I do in here? Well, first, let's do a for each loop too. For int value in my ints. Okay, so this is a for each loop. It's going to get each value out of the my ints array, and we'll just print them out. Print out each of the values. Okay, so I didn't actually set anything. This for loop up here is doing nothing. Okay, we're going to have it do something in a second. So this for loop's not doing anything. We created the array. You saw with strings when I created an array and didn't set any values that we got null values. What happens for ints? We get zeros. So by default, numerical types like ints or floats or doubles, they get set to the value 0. So if that doesn't hurt anything, you can remember that ints or doubles or whatever numerical type you're using, they're automatically initialized to 0. If we want to initialize them to something else, we can do it in a loop here. So I could say my ints sub I, let me set them all to 10. There, I set them all to 10. Let me set them all to 10 times I. So the first time I equals 0, 10 times 0 is 0. 10 times 1 is 10, 10 times 2, 10 times 3, all the way up to 10 times 9. All right. So we can use a formula to initialize integers if we want to. Let's stick with this. Actually, let's change it to 5s. And let's go less than or equal to here. Let me change less than. This is important to watch. Look what happened. This is something you have to be careful of. An exception in thread main Java. Index, array index out of bounds exception. The index 10, okay, so I used less than or equal to here. So it tried to access my ints and put a 10 in there. And remember, we have 10 values, but they're numbered 0 through 9. There is no number 10. And if you try to access an index that doesn't exist, you will get this out of bounds, array index out of bounds exception. So be careful of that. I wanted to show you that. Boundary conditions are important when you start working with arrays. Arrays can't grow, they can't shrink, and you can't access a number that doesn't exist. So if your array was set to 10 values, they're numbered 0 through 9, don't ever try to use a 10 or an 11 or a 12 or anything else that isn't a valid index. All right, so we're counting 0 to 45. I'm going to show you something called an accumulator. Sometimes we want to do a running total of things that are held in an array, numerical values held in an array. So we use a variable called an accumulator. Now I like to use the the analogy of the junk drawer that you probably have in your kitchen. Everybody has a junk drawer somewhere in their house, right? And that junk drawer started out as an empty drawer in your house. And at some point, somebody didn't know what to do with an item. So they threw it in that drawer. And later on, somebody had another item. They weren't sure where to put it. So they put it in that drawer. And then somebody found another item and they weren't sure where to put it. So they put it in that drawer. And that drawer started accumulating a bunch of junk, right? Okay, so an accumulator variable is like that empty drawer. It starts out empty and we just keep throwing stuff in it. Okay, so an accumulator variable does the same thing. So I'm going to create an int called total. And I'm going to set it equal to 0. Okay, so my total starts out being 0. But every time I go through this loop, and I set these new values, I'm going to add to my total. Total equals total plus my ints sub I. Right? So I'm going to throw whatever this value I set here, I'm throwing that value into my accumulator. And I'm adding it in. So it's going to start out, it's going to add 0, then it's going to add 5, it's going to add 10 to that, so we'll have 15. Add 15 to that value, we'll have 30, and so on and so forth. And in the end, we should be able to print out the total of our array. Put a colon here and a space to make it look nicer. All right, so we added them. Every time this looped through and created a new value for my ints, we added that to the total. And when our loop was done processing, we printed out that total, and it was 225. So you can use this accumulator variable, to find a total, a grand total of a bunch of values that are held in an array. That's a technique we use a lot. Let's take that one step further. I could also do this. Print out the average. How do we find the average? Well, we take the total. Notice I put this in parentheses, and divide it by my ints.length. Okay. This has the number of values that we added up. This has the total of those values. So if we divide them, we should get the average. And the average is 22. So all those numbers added up are 225. We divide it by 10, and I get 22. Now, technically, I think that should be 22.5, right? So this is where our integer division comes in. I took an integer, I divided it by integer, I got an integer. So if we wanted to do something and have this be a double, we might want to cast it. See if I can do that. A little review of some things here. Let's cast it as a double. And it should work to just take the total, cast it as a double, and then divide by the integer. And now we get 22.5.